The next tab is the Lateral Earth Pressure tab. You can calculate the earth pressure using either the Rankine method or the equivalent fluid pressure method. If using the Rankine method, then you need to input the phi angle of the soil as well as the soil density. You can also account for any surcharge on the retained soil by inputting that value in PSF. And if your backfill has slope, then you can input that information here as well. The passive pressure is automatically calculated based on the Rankine equations. You can also apply a safety factor to the passive pressure to calculate the allowable passive pressure. For example, if you use a safety factor of 2, then the allowable passive pressure will be 180 pCF. Lastly, you can input how much of the topsoil is to be neglected for passive pressure calculations. We will keep this as 12 inches. The active pressure is also automatically calculated when using the Rankine method. I will change the safety factor for the passive pressure back to 1 for the purpose of this example. Alternatively, you can use the equivalent fluid pressure method. The required input data is slightly different if you use this method. You will need to input the equivalent fluid pressure, which will then be used to calculate the active pressure. Also, you will need to input the passive pressure value on your own as well, since it is not being automatically calculated. For the purpose of this example, we will stick to the Rankine method, so we will toggle back to it. The last tab is the lagging tab. You can click on this box if you are using lagging. This is an analysis tool and it does not design the lagging for you. You can input the lagging depth and it will provide you with analysis information. For example, let's use 6 feet of lagging depth. You can then take the calculated moment and shear values to design the lagging separately. For our example, we will uncheck the lagging option. Now that we have finished inputting the required data, let's take a look at the sketch on the right-hand side. You can already tell that the current design does not work. This is because the sketch lets you know that you need an additional 20.86 feet of embedment for this pile to work. This is in addition to the 15 feet of embedment that we already have. If you click on the Summary tab, you can see itemized results. You can see the soil active and passive pressure coefficients as well as the lateral loads. PA is for active pressure and PW is for the lateral pressure resulting from the surcharge. We did not apply any surcharge loads, hence PW is 0. Next, you get the max moment and max shear on the pile as well as the depth to where the max moment occurs. The result will also include the maximum deflection at the top of the pile. The next section covers the required embedment versus the provided embedment. The user manual has a deeper discussion on how the required embedment is calculated. Lastly, you will have the status checks. This shows the applied max moment and the applied max shear, as well as the allowable moment and shear capacities. You can see here that the status is shown as NG or not good for moment and embedment, while it is okay or acceptable for shear. If you like to learn more or have any questions, you can visit our website ENERCALC.com or send us an email at support@enercalc.com. Thank you for watching.